Hello, it's me, still alive, don't worry. I'm back with another Logic Analyzer themed video. I've been working hard on learning how to use KiCad to design PCBs, and I've come up with a good version of the Logic Analyzer interface for ZX Spectrum. So I'm very excited to show you how we can wirelessly extract a full decode of the Z80 data bus from the edge connector of our ZX Spectrums. So let's get on with it. I can't wait to show you. So here is the package finally from PCBWay with the new version of the Logic Analyzer interface. I'm extremely excited to get this built, so let's cut into it carefully and slide one out. Here it is, shiny and new, and with tinned edge connectors it seems. I guess I must have requested that when I made the order. I'm already noticing that the mounting holes seem a little bit close to the edge. It's not too bad, but I think I might do another revision with another 0.5 mm or so added on to that clearance. I also have ordered some assemblies of Eldrgusman's Logic Analyzer. You can order these through the link on the GitHub, link in the description, and PCBWay are great. They even send some pictures of it before they commit to soldering to make sure that you're happy with the orientation of the chips and everything like that. Why not give it a try? Head to the GitHub, find the link to the PCBWay assembly, and you'll be faced with this. I'm going to show you just how easy it is to order one of these for yourself. All you need to do is click PCB and assembly and add to cart. Type in how many you want, decide if you want PCBWay to source the parts, which makes sense to me, take the load off you, and then you can choose things like the solder mask colour and the silkscreen colour. Easy peasy. If you're still not sure, there's even a little tour which will take you around the steps which you need to go through to order a PCB, but believe me, it's easy. I've gone for green PCBs this time for a change, and all I need to do is solder a Pico to it. So here's our two main parts. We've got the Logic Analyzer and the Logic Analyzer interface. We're going to need this big 1N5820 diode to stop USB from inadvertently powering the Specky if you plug in one of these Picos with the Specky turned off. Here's our two Picos. I'm using PCBW's, and oh yeah, we're going to need an extra Logic Analyzer board, a button for the reset, we're going to need an edge connector, a few sockets, and a couple of headers. Is that it? Oh, here we are. We need these supports too. These spacers are going to add some structural stability to the whole assembly. We're going to need some 1x3 sockets and some headers to make 1x3 headers. More on that later. Here's the old design. This is version 3.0, and the issue that I found with this one was that the spacing of the headers is too far apart. I'll show you now. You can see this is an assembled one, and if I take a assembly of Logic Analyzers, here we are, two of them, plugged in together with the spacers, and the headers and sockets are all plugged in together as well. I try and put them into the interface, and it's not spaced correctly, as you'll see. They're just too far apart, only a fraction of a millimeter. Well, it does give me a good reason to make a new revision, which is where version 3.1 came from, which also includes mounting holes for a case, which is nice. So here's version 3.1, this is the new version. It's got the 4 mounting holes, which are a little bit too close to the edge for my liking, and I've also moved the headers a little bit closer together, had to do a little bit of rerouting, had to move these silk screens around, the little happy transistor and the text there. What do you think? Is that mounting hole too close to the edge? Crucially, the spacing of the headers is right. I'm just testing it here by popping the Logic Analyzer assembly in, and they go in no problem, so it's going to line up once we've soldered the sockets in. The tricky thing about this assembly I'm finding is getting the edge connector on. You can see that the edge connector is way too wide for a 1.6mm PCB, so you need to do some bending of the pins. What I'd really like is a jig to do that for me, so if anyone knows of any such thing, let me know, because I'll pay through the nose for one. What you're about to see is me trying to bend these pins into place using pliers. I know that you can just kind of lean it on the desk, and this is what I did in this assembly, but I find that that means the pins aren't really flat to the board like I want them to be, like this, and that's the ideal case in my opinion, but it just requires a lot of manual faffing around. As you'll see, here we go. So that's all of them kind of roughly bent into place, and I'm finding that by applying some force with a fairly hefty set of tweezers to each pin allows me to bend the angles into the legs while it's kind of straddling the PCB, and I can get them to look fairly flat to the board, although everything is a tiny bit wonky to be honest after all that manhandling, so there must be a better way. It's on there anyway, it's straight and all the connections are good. So we can move on to the more easy task of soldering the other components to the board. Let's start with the sockets. I'm using 4 1x16 sockets because I just could not find 2x16 sockets for any reasonable price. They go on okay as long as you're careful to put them on straight. Now for the big fat diode. Is this overkill? I'm not sure. The USB output of your computer can deliver, a fair bit of current. I don't know, what do you think? Let me know. We need to apply a lot of heat because this is a really thick leg on this diode, so let's spend some time making sure that these joints are good and then trim them down. Now for the reset switch, don't really need this, but it seems daft not to stick a reset switch on a speccy peripheral if you've got the space to do it. It's just a standard one that you'd get with an Arduino kit, so in that goes. And that's it, that's our Logic Analyzer interface assembly assembled. God, that's a mouthful. So, moving on to the logic analyzers themselves. We're going to have to remove this socket and this header so we can put the vertical ones on in such a way that they stack in a nice way to go into the back of our specky. So let's get them removed. I could not justify cutting them off, so I removed them carefully, and that should save me from getting some flack for wasting components. Here's our Raspberry Pi Pico going on. This is the Raspberry Pi Pico W, as I mentioned. Pico 2W will be getting Wi-Fi support. I do have a test firmware for it, but for now I'm sticking with the Pico W, and maybe the Pico 2 can go on as an upgrade later. Now for our sockets and headers. So we're going to have to put the vertical socket and header onto the top side of one of the boards. We'll do that now. And then we're going to do the same thing on the underside of the other board, and we're going to be careful to make it in such a way that the header on the underside of this board is opposite the socket on the first board. You don't have to do this with your boards if you don't want to. They'll stack nicely with the spacers and you can just use jump leads to connect the daisy chains. You do need to connect these though, so I like to do it this way and keep everything as neat as possible. And you can see how they go together now, just like this. You'll also see why I decided to include some spacers in this assembly, because this isn't very structurally stable, so the spacers are going to make this really nice. Don't forget to switch these slider switches over to 5 volts because we'll be working with 5 volt logic from the back of the specky. Lovely. Here are the spacers. It took a bit of trial and error to get the right ones. These ones are perfect, and I have a bag full of ones which don't fit. I'm not sure what to do with them. They pop in nicely, and then you can push the whole assembly together with a nice crack when the spacers connect. Do take a moment to make sure that the 3x1 headers are connected properly before applying any force. Then you can crack in the 3 spacers and you have an assembly. Lovely. This is capable of recording 48 channels, which is more than enough to get a full decode of the Z80 buses within our spectrum. Let's put the whole thing together. Here we go. If you're very observant, you may have noticed that I've grabbed the earlier version of the interface here, which is just a mistake on my part. Version 3.1 will reappear at the end of the video. And there we are, it's all assembled. Lovely. What do we need to do now? We need to set up our Raspberry Pis. So let's connect a USB cable to our computer, starting with the Raspberry Pi Pico at the back. You'll see it comes up a bit like a USB drive. You can see the contents of it. What you need to do is go to the Logic Analyzer GitHub page, link in the description below, and find the firmwares. Where are the firmwares? You need to find the releases section. Here it is under downloads, and here you can download your Windows software or Linux software and the firmwares. In fact, while we're here, let's download the latest Windows software. I can't really talk you through doing this on Linux because I'm rubbish at that and I don't have a Linux machine. So here we are, I'm downloading the WinX64 version, and just extract that to a folder where you want the software to live. Scrolling down, we can find another section which contains Logic Analyzer firmwares. Version 6 at the time of recording is what's available, and we need to download the appropriate one for the Pico that we're using. So I'm using a PCBW and I want to use the Wi-Fi capability. So I'm choosing the PCBW Wi-Fi download file. Downloads a zip file which contains one UF2 file. All you need to do is drag it into your Pico storage which has popped up when you plugged it in, and it will disconnect itself from the PC, and you have a configured Raspberry Pi Pico. Lovely. Now let's move the USB to the other Pico, the one in front this time for my case, and we'll do the same thing again. Just drag the UF2 file onto it and it will set itself up. If it's not showing up as a storage device, hold the boot select button on the Pico while plugging it in. Next step, we have to install Python. So go to Google, type in install Python, and you'll find a link to download Python. I'm not using the latest version just because I already have an earlier version installed, but whatever, download the latest version. Install it and then rejoin us here. You need to find this folder, this app data folder, so this is where it is for me. C users Jim, app data local, programs Python, Python 312. Might be a bit different for you if your name's not Jim. Find the Python DLL, so for me it's python312.dll, and you need to copy the path. So let's copy the path from there. Next, go to your Logic Analyzer software folder where you extracted that zip file earlier, and you need to make a new text document and open it up to edit it and paste in the address followed by another backslash and then python312.dll or whatever your DLL file was called. Save it and close it. Now you need to rename your file, so it's called new text document.txt. We have to rename it to python.cfg. Where the hell is rename these days? There it is, rename. Now rename the whole thing including the extension to python.cfg. This is going to enable you to use the decoders, which I think is really important. If you can't see the extension, i.e. if you can't see .txt at the end of the file name, go into your folder options, which you can find here. Go to the View tab and scroll down and find Hide Extensions for Known File Types. Not that one, this one. Hide Extensions for Known File Types, and make sure that it's unchecked. Click Apply, click OK. Then you should see the .txt extension and you'll be able to rename it to a .cfg file. Now you can run logicanalyzer.exe and it's going to launch the app. Lovely. Alright, welcome to the app. Now you should have one of your Picos still plugged in, so hit refresh up here. In the drop down you can see it under COM 3 or 4 or 5 or 6, it'll be different for you, but you'll see something which is your Pico. Select it and then you can click open device and you'll see that it recognizes a logic analyzer under the current device. Go to network settings, update network settings, and you need to type in the name of your Wi-Fi network that your computer is connected to. For me it was Vodafone C something something. Make sure you get it exactly right, type it into there, and also you need to type in the password that you have to type in to connect a device to that Wi-Fi network. If you haven't changed it, it will be on the label on the back of your router. I'm blurring mine just in case anyone wants to sit on my drive and steal my bandwidth. Now type in an IP address that you want your Pico to have. So start it with 192.168.1. something. I'm using 42 and 43 for my two Picos. Now I just remembered that this Pico I'm configuring right now is the one at the back of the assembly, so I'm going to give that 43, so that's the slave, and I'm going to give the one at the front of the assembly 42 as the master. And we see network settings updated successfully, which is what we want to see. By the way, if you don't want to use the wireless connection, you can just plug in two USB cables and crack on from there. Just fast forward a little bit past this Wi-Fi setup. With that done, I'm plugging in the other Pico. This is the one at the front of the assembly. Same thing, but I'm giving it an IP address ending 42, and that will be my master device. You'll see later we need to configure a master and a slave. Good. So let's bring in a specky. Here we are. This is my Harlequin 128K, but this interface and these logic analyzers should work with any spectrum all the way up to the next, which is great. Plug it in, it fits, And the first test I'm going to do, because this is the first time I've tried one of these out, is to plug in a composite cable so I can see the video output and power it up and see if the specky falls over, see if the PCBs are somehow causing an issue. Hopefully they're not. And they're not. Good. Okay, now we can move on and take some measurements. So what do we need to do? We need to change the setting here from auto detect, or whatever it's on for you, to, well, let's start with network. So choose network and then click on open device, and you can type in the IP address of, let's go with the master device. For me it ends in 42, and you can see that it sees it, and it says Logic Analyzer Wi-Fi v6.5. You can even start capturing and configuring your channels. I've got them preset here as all of the address lines. Click OK, and we're going to see some wiggly lines any second now. There we go. We have a Logic Analyzer trace. Cool. Let's try the other device. So go back to network, click on open, change the IP to your slave Pico. For me it ends in 43, and it's found it, and I can also take a capture if I want. Let's try it. Repeat last capture. Obviously the channels aren't going to reflect what it's actually connected to in this case, but we're just checking that we have a connection. That's good. Now here we go. Let's go to multi-device, open device. Now, what is our master? Well, it's network. It's not a COM port. It's connected via Wi-Fi because our USB cables are unplugged. And we can go and type in our IP address of the master, which for me ends 42. We'll switch on slave 1. That's also network. And we'll choose the IP address ending 43. And yes, you could have 4 slaves if you want and measure 120 channels, which obviously is overkill for this application. Click accept, and you can see it says multi-analyzer. It's worked. Now we can configure a capture. I suggest you take some screenshots and copy this setup, because all of these channels will be exactly as yours should be if you're using the same setup as I am. This will give you everything that the ZX Spectrum has to offer on the Edge connector, and it will enable you to get a full decode of the Z80 data buses. So note these down and spend some time typing all of these channel names in. We also need to set a condition for triggering. You can see I've been messing around with the pattern trigger. First channel, channel 1, and I've been looking for all 1s. So let's just change that to 0 for a very simple trigger. It will trigger when, in this case, A15 goes to 0. Frequency of 20 MHz works for me. I've got 512 pre-samples and 10,000 post-samples. You can have more, you can have up to 30,000 with the Pico. Click accept, and it's going to take a capture once it sees the pattern, which will happen almost instantaneously. And there we are, there's our trace. We can scroll down through all of these different channels and see everything that's happening on our ZX Spectrum Edge connector, which is super nice. Now remember that we chose 10,000 post samples with 48 channels logging. It looks like this. It's quite a lot for me, plenty for any debugging or any messing around that I'm trying to do. Now let's have a look at this pattern trigger. I obviously just had it set on looking for 0 on channel 1. I'm going to try putting in a pattern, alternating 1s and 0s. Actually no, I'm going to go with 0, 1, 1, 0, 1, 1, 0, 1, 1. Don't know why, I just fancy using that pattern. So let's click accept. It's going to listen for that pattern, and when it happens it will fire off and send all the data over the Wi-Fi network to our PC. And we can see that it has found a 011, 011, 011 pattern. So you can look for any address you want to appear and use that to trigger your measurement. Cool. Now here's a really nifty bit. We're going to get the SIGROC Z80 decoders set up. So type Z80 into the search bar here, click the plus button, and then expand it down and just populate all of these channels. You should have named the channels correctly, and it'll be easy to know what to choose. So D0, we choose D0, D1, we choose D1, and so on and so on and so on until you've populated them all. When you've populated all of the red ones, that's the minimum you need to get some data. You get to see the data bus, the instructions and operands along the top. But let's keep going and populate all of the green channels, and we'll get a full decode including addresses. Give it 1 second after populating them and you'll see the address bus appears at the top in orange, decoded into hex. Cool, there we have it. That's our wireless logic analyzer working in the back of our ZX Spectrum non-invasively. Awesome. What else can we look at? I don't know where to start with this really. I think it's so cool for educational and debugging and just general tinkering. One thing I do want to look at is the clock signal. This is the clock into the Z80 which the ULA generates. You can see that it pauses every now and then. The ULA does that on purpose so that it can access the data bus to fetch some graphical data to output to the screen, so the Z80 doesn't fight it and cause problems with the graphical output. Cool to see that happening in front of our eyes. And there it is, plugged into our Harlequin. I've got the dandanator in the back through the pass-through edge-through connector, allowing me to play games while analysing the logic of those games. Cool. Does that have copyright implications? Because you could kind of decipher the code. I'll leave that one to the comments. Anyway, I'm really pleased with this. Check it out. There's one last step. I want to put heatsinks on the Picos, only because the first one I received from Eldrgusman had a heatsink on, so I'm going to copy him because he's the guru. I've gone for a lovely shiny green. I'll stick a link in the description to the Amazon page where I got these. So I'm going to release the Gerbers for this logic analyzer interface. For now, just join the Discord and ask me, I'll send them over. You can have a go yourself. If you're not up to ordering Gerbers or you don't want to assemble it yourself, let me know. I'll put one together for you. And if you want to order some logic analyzers, head to the GitHub link in the description and you can order some from PCBWay. If that's a bit much, let me know. I'll be able to put together a full assembly for you of this and I'll test it too. Just give me a minute to finish testing this. I've sent one out to the wonderful Lee at More Fun Making It. Go check him out, he's going to have a go with it too. Let me know how you get on, Lee. And thanks everyone for watching. I hope that was interesting. I'm really proud of this and I'm looking forwards to making more gadgets in the future.